Okay, let's get back to coding. This question is called tasks and deadline. Basically, there's n tasks. Each task has a duration and also a deadline. And then our kind of task is to kind of make up the order such that we maximize our reward. And how the reward is calculated is D minus F. Basically, D is the deadline and F is the finishing time. And then all tasks have to be processed even if the reward is negative. So yeah, so we're trying to optimize this reward. And our input is in the number of tasks and then the A and D, which is the duration and deadline. And we're just trying to find the optimal reward for that. So the idea behind this is, okay, there must be some kind of way that we order it such that our D minus F is optimized. So we're just gonna assume that, okay, um, the equation for our total reward would be something of the form D1 minus F1 plus D2 minus F2 all the way up to Dn minus Fn, right? By definition. And then we can just regroup this such that all of our D's are in the front and then we're minusing all of our F's, some of the F's. So that means that essentially the D's are already set in stone. There's nothing we can do to change it. So it's constant, and the only thing we can change is actually the finishing times. And in order to maximize the total reward, that means that we need to minimize the um, sum of F finishing times. So that would mean that in order to minimize that, we need to kind of order the tasks in order of their duration from the shortest to the longest. So that's essentially what we're going to do is we're going to define such a thing that we're just going to compare the duration, order it, and then just do everything, the greedy approach. Okay, so let's go through the code to kind of, we already went through the strategies, let's go through the code. So we're just going to import everything, use namespace std, define long because just do not exceed the additional things. And then we have we're just going to define our own structured task, which has a duration and also a deadline. And now we're going to define our own kind of comparison by kind of comparing the two things using the duration of the thing because we want it to be ordered by the shortest duration to the longest, right? So in our main, we're going to just make our input fast and output faster by these. And then what we have is our in, we input in, we define a vector that consists of tasks, our own defined structure um, with in values inside. Then what we do is we just input it based on the duration and the deadline, and we're going to sort it based on our comparison. So we're going to sort it by the duration. And how it's going to work is now we're just going to go through the definition of just calculating everything, right? We're going to have a current time and a max reward counter. And then we're going to go through the for loop of each element. How it works is our current time, we're going to add the duration of the thing, and then our maximum reward would just be the deadline minus the current time. So yeah, it's going to be added, and then we go through the entire list, so we're going to get the thing. And then finally, we would output our max reward and return, and we're done. So overall, I think the main takeaway from this problem is kind of um, thinking about writing an equation, like an actual representation of what the problem is asking for, of the optimal reward. Once you have that equation and you realize some things are constant, like the D's over there, then it means that F has to be minimized. And if F has to minimize, then we just take the greedy approach of every time taking the shortest, right? By duration. So it's pretty, I think once you kind of list out that equation and go from there, I think the rest of the problem is fairly doable. End it off here.